I see a problem here. We're using a GammaRegressor from Sklearn to predict the time until some event happens, like a machine breaking down. The problem is, the model sometimes predicts negative times, which is impossible in real life. The question is to figure out why this is happening and how to fix it. This statement is incorrect. The gamma distribution, in its standard form, only deals with positive numbers. Think of it like this: you can't have negative time until something breaks. Underfitting is when the model is too simple to capture the data's patterns. It could lead to bad predictions, but it doesn't directly explain negative time predictions. This is less likely to be the root cause of the negative predictions. This is correct. Before I feed the data to my GammaRegressor, I can change it, say, using a logarithm. This makes sure that all my values are positive, fixing the problem of negative predictions. Another good point: the alpha parameter is like a dial that changes the shape of my gamma distribution. If it's set wrong, I might get silly predictions, including negative ones. I should carefully adjust this hyperparameter. To solve this, I need to understand the gamma distribution, how the GammaRegressor works, and some common ways to adjust data before modeling. I need to know the math behind the gamma distribution. I need to know how to use Sklearn's GammaRegressor, which is a tool to model this distribution. And I need to know how to prepare data by adjusting it before using it to make a model. This is all super important. This question asks you to identify the correct statements about why a GammaRegressor model, used to predict time until an event, might be giving negative predictions. That's a problem because time can't be negative. Let's examine each option carefully. We are using a GammaRegressor, a statistical model that fits a gamma distribution to our data, to predict how long until something happens. The model is outputting negative numbers, which is impossible in this situation. This question wants you to find out what's wrong and how to fix it. I'll examine each possible solution provided in options A, B, C, and D to find the most likely reason for these negative predictions. I will analyze each option step by step, considering the properties of the gamma distribution and the Sklearn GammaRegressor model. This suggests that before I feed the data into the model, I could change the target variable, the time until event data, by applying a mathematical transformation, such as a logarithm. This would make sure all the values are positive, a requirement of the gamma distribution. This is a great way to make sure the input is suitable for the model. The gamma distribution's shape is determined by a parameter called alpha. The GammaRegressor might be producing incorrect predictions because this alpha parameter is not optimally set. I could use techniques like grid search or cross-validation to find a better alpha value for more accurate predictions. This is incorrect because gamma distributions only represent positive values. That's the problem with getting negative values. The gamma distribution can't have them. Underfitting is when the model is too simple to capture the pattern in the data. But this doesn't directly cause negative predictions from a gamma distribution. While a better fit would improve the model generally, it doesn't solve the negative value problem, so it's less likely the root cause. The core problem is that Sklearn's GammaRegressor, which I use to predict time until an event, is giving me negative predictions. This is impossible because time can't be negative. That's what makes this problem so interesting. I'm getting negative numbers as predictions when I should only be getting positive values for time until an event. It's like my model is telling me the event happened before it even started, which is obviously incorrect. This is a big problem that I need to fix. I'm investigating why I'm getting negative predictions. There are a few reasons why this could happen. Could it be a problem with my data, or the way I've set up my model? I need to find and fix the issue, and I'll look at a few ideas. This statement is incorrect. The gamma distribution, which the GammaRegressor uses, only works with positive values. It's like trying to fit a square peg in a round hole. It just won't work. So I know this isn't the answer. Underfitting could be a problem, resulting in poor predictions. But it doesn't explain why I'm getting negative values specifically. It's more of a general issue rather than the direct root of negative predictions. I could improve it by adding more data or adjusting the model's complexity, but that's not the direct problem in this case. This is a great idea. Before I feed my data to the model, I could change it using a transformation, like a logarithmic transformation. to make sure all the values are positive. This way, I'm giving the model data it can actually handle, and this directly addresses the negative prediction issue. This is a correct solution. The GammaRegressor has settings, called hyperparameters, like the alpha parameter, that control its behavior. If I set these incorrectly, it might lead to poor results, including negative predictions. I could adjust these settings using techniques like grid search or cross-validation to find the best settings for my data. This is also a correct solution. I could use different techniques to prepare my data, like the log transform in option C, before I train the model. Preparing data like this often fixes problems. I can adjust the model's settings, hyperparameters, to improve the model's predictions. This is often a solution to prediction problems. The best ways to fix this are to transform my data, C, and adjust the model's settings, D. Those are the correct solutions! Exclamation mark. We're using SKITLEARN, SGAMMAREGRESSOR to predict the time until an event happens. But the model is giving us negative predictions, which is impossible since time can't be negative. We need to figure out why this is happening and how to fix it. The GammaRegressor has a setting called alpha that controls the shape of the gamma distribution. If this setting is wrong, the model might produce unrealistic results, including negative predictions. So, we might need to carefully adjust the alpha value to make the model work better. I think we can also try changing how we present the time data to the model. For instance, we could use a logarithmic transformation, which converts all the numbers into their logarithm. This ensures that the data passed to GammaRegressor will only contain positive values, which is required by the gamma distribution. We're tackling a prediction problem using Sklearn's GammaRegressor. The model predicts negative values, which is impossible for the time-to-event data I'm working with. It's like predicting a negative amount of time until something happens. That's not physically possible. I'm using a GammaRegressor to model when an event occurs, like a machine breaking. But the model sometimes gives negative predictions, which is totally wrong. I need to figure out why. I could try changing the way I represent the time-to-event data. Maybe a logarithmic transformation will help. This ensures the model only gets positive values. It's like changing the scale to make everything fit. The model's settings could be off. Maybe tweaking things like the alpha parameter could solve the problem. It's like adjusting the dials to get the right fit. I'll experiment with different settings to get a better fit for my data. I think options C and D are the best solutions. By transforming the data, I make sure it's suitable for the model. And by tuning the model parameters, I get a better fit to the data. This is the way to deal with negative predictions from a GammaRegressor. That's incorrect. I know the gamma distribution only works with positive numbers. Thinking about it like a timer that only counts upwards, it can't go into negative seconds. Therefore, a gamma model shouldn't predict negative values. This is a smart idea. If you're dealing with positive time data, you can make it work with a gamma model by changing it first. A log transformation is a great example. It shifts positive numbers only, making it a good fit for gamma models. Absolutely. The alpha parameter in the GammaRegressor controls the shape of the gamma distribution. If you don't set alpha correctly, the model may make inaccurate predictions, including negative ones. Fine-tuning the parameters can be a great approach to improving model predictions. We are trying to solve the problem of our GammaRegressor predicting negative values for time. That doesn't make sense because time can't be negative. The problem we're discussing involves the Sklearn GammaRegressor, which is producing negative predictions for what should be positive time values. This violates our understanding of time as always positive quantity. We're tackling a problem where a GammaRegressor, a machine learning model, is making predictions that don't make sense in the real world. Specifically, it's predicting negative values for something that can't be negative, like time until an event happens. This is a classic example of a model not matching the nature of the data. The heart of the issue is that our model, the GammaRegressor, is spitting out negative numbers. This is impossible when you're modeling something like time to failure. Time can't be negative. We need to find out why and fix it. This is where you, Vamsi, will apply your knowledge to choose the solutions that will solve the problem of negative predictions. It's a multiple choice question, so there could be multiple correct answers. Let's see if you can get them all. This is it, VAMSI. This is where you decide which solutions best address the issue at hand. You've analyzed the options, now apply your knowledge and make your choice. Good luck. I know you'll ace this. This option says negative predictions from a gamma distribution are fine, but that is incorrect. The gamma distribution only works with positive values. This suggests the model is too simple, needing more data or a more complex structure. While this could affect the prediction accuracy, it doesn't directly explain why we're getting negative predictions. This option suggests a fix. Change the data before feeding it to the model. For instance, a logarithmic transformation, taking the logarithm of each data point, could work if all values are positive to begin with. This ensures the model only sees positive numbers, thereby solving the issue. This is a great solution, VAMSI. This points out that the model's settings, hyperparameters, might be wrong. The alpha parameter is mentioned. It controls the shape of the gamma distribution. If alpha is set incorrectly, it could lead to negative predictions. Tuning these settings through methods like grid search or cross-validation can help find the best setting for the model.